If we have a horizontal line and an angle looking downwards, the angle that is formed is known as the angle of depression. And if we have a horizontal line and an angle looking upwards, the angle that is formed is known as the angle of elevation. So we can see that it looks like a set of parallel lines with a transversal cutting through. So for example, this angle here would be equal to this angle here because they are alternate angles. But angles of depression and angles of elevation do not necessarily come up inside parallel lines. A vertical mast CD of a height h meters stands on a hillside inclined at an angle of 15 degrees to the horizontal. From a point A below the mast, where AC is equal to 20 meters, the angle of elevation measured to the horizontal of D is found to be 57 degrees. Part 1. Find the measures of all the angles in the triangle ACD and hence find the value of h correct to 2 decimal places. Part 2. If B is a point on the same line as A and C, but is above C on the hillside and CB is equal to 10 meters, calculate the angle of elevation measured to the horizontal of D from B. Give your answer correct to the nearest degree. So here we have the triangle ABD. We see that CD is the height of the mast, the vertical mast. We have an angle of 15 degrees, an angle of elevation. We have the distance from A to C is 20 meters and the distance from C to B is 10 meters. So part 1, we're trying to find the measures of all the angles in the triangle ACD and hence find the value of h correct to 2 decimal places. So the triangle ACD, this triangle on the left of the larger triangle. So we're trying to find all the angles in the triangle. And we're also trying to find the value of h, which is the mast CD, the vertical mast. So we're told in the question that the angle of elevation of D from A is 57 degrees. So it said the angle of elevation measured to the horizontal of D is found to be 57 degrees. So the angle DAC is going to be 57 minus 15 degrees, which is going to be 42 degrees. So the angle from the horizontal up as far as point D altogether is 57 degrees. And we know that this angle of elevation here is 15 degrees. So 57, take away the 15, leaves us with 42 degrees. So this angle in here, angle CAD, is 42 degrees. Also, the angle ACD, so ACD, so this angle in here, is going to be 90 degrees plus the angle of elevation, which is 15 degrees, which is 105 degrees. So this angle here is 105 degrees. And we can see this a bit more clearly if we draw in another parallel, a line that's parallel to this line here, the horizontal. So drawing in this line, which is parallel to the horizontal, we know that if this angle is 15 degrees, then this angle must also be 15 degrees because they're alternate angles. And we can clearly see that this is a right angle, which is 90 degrees. So the 90 degrees plus the 15 degrees gives us 105 degrees. So that's where the 105 comes from. Then by subtraction, the angle ADC is going to be 180 degrees because the angles in a triangle add up to 180 degrees, minus 105 minus 42, which is 33 degrees. So this angle here is 33 degrees. So now we have the three angles and we just have to find the side which is labelled as h, the height. So since we have an angle, 33 degrees, and its opposite side, which is 20, so the green line is 20, we can see it more clearly up here in this diagram. So since we have an angle and its opposite side, we're going to use the sine rule. So the sine rule we know is A over sine A equals B over sine B equals C over sine C, but we only ever need to use two ratios. So if I have this already labelled as capital A, 42 degrees, then I'm going to label this as lowercase a. This is already labelled as capital C, so this can be lowercase c, but since I don't actually have a value for it, I'm not going to bother labeling it. And then this is going to have to be labelled as uppercase B or capital B, the 33 degrees. And then the 20 is going to be lowercase b, the side 20. So subbing into my formula, I swap the a for h, so I get h over sine of a, which is going to be 42 degrees. Sine of 42 degrees is equal to, I swap the lowercase b for 20, and that's all over sine of b, which is 33 degrees. So h over sine of 42 equals 20 over sine of 33. I'm going to cross multiply and solve for h. So I get 20 times sine of 42 as my numerator, and I get sine 33h, and I'm going to divide across by sine 33 to get the h on its own. So I get h equals 20 sine 42 over sine 33, which gives me 24.57 to 2 decimal places. So the height of the mast is 24.57 meters. Part 2. If B is a point on the same line as A and C, but is above C on the hillside, and CB is equal to 10 meters, calculate the angle of elevation measured to the horizontal of D from B. Give your answer correct to the nearest degree. So we're trying to find the angle of elevation measured to the horizontal of D from B. So this is D and this is B. So we're trying to find the angle of elevation of D from B. So I'm going to have to draw in the horizontal so we can see better what we're looking for. So this is the horizontal line, and this is the angle of elevation of D from B. So this is what we're looking for. So since this is 15 degrees, and this line is parallel to this line, and we have a transversal cutting through, then this angle here is alternate to this angle here, so this angle here is 15 degrees. So if we were to find this full angle here, and take off the 15 degrees, we would be left with the angle that we're looking for. So I've added in the 24.57, which is the vertical mass that we found from part 1. And I'm going to start by taking the triangle BCD. So for the triangle BCD, so I've drawn it out separately here, BCD. And remember, I'm going to try and find the full angle of angle DBC, the full angle, and take away the 15 degrees. So I've labelled this angle here as theta, and I'm going to fill in the other bits of information that I know. So remember, I figured out that the height was 24.57, so label that 24.57. I also know that this angle here is 105 degrees, and that this is a straight line. So 180 minus 105 leaves me with 75 degrees. So this angle here is 75 degrees. I also know that CB is 10. I was told that in the question. And that's all the information that I have at the moment. Okay, so I have a side, an included angle, and a side. So I'm going to use the cosine rule. The cosine rule is a squared equals b squared plus c squared minus 2bc cos of a. So I need to label my triangle. So since there's a capital A in my formula, that means the angle that I have has to be labelled as capital A. So the 75 degrees gets relabelled as A, and the side opposite it gets labelled as lowercase a. Now I haven't figured out yet how I got the 24.01. So then I'm going to label angle theta that I'm looking for as C, and the side opposite that is lowercase c. And then the other angle is going to be B, and the side opposite, that which is 10, is going to be lowercase b. So I substitute into my formula. A squared becomes BD squared, because I don't know that. So BD squared. B squared becomes 10 squared. Plus C squared becomes 24.57 squared. Bring down the minus 2. Swap the B for 10 with brackets around it. Swap the C for 24.57 with brackets around it. And cos of A becomes cos of 75 degrees. all of this into the calculator, you get 576.5, and getting the square root of that gives you 24.01. So BD is equal to 24.01, which I've labelled as A. So remember, we're trying to find this angle theta. So let theta be the angle CBD. Then we're going to use the sine rule. So again, for the sine rule, we only ever use two of our ratios. And since we're looking for an angle, we're going to put the angles on top. So we have sine C over C equals sine A over A. But it doesn't matter if you do it upside down because it'll still work out so long as you cross multiply and solve. So you could alternatively add in the other part of the sine rule, which is sine B over B. But we don't actually end up using the B parts for this formula. So it's okay just to write down the two ratios that you do use. So sine C becomes sine theta. And that's divided by lowercase c, which is 24.57. And that's equal to sine of A, which is sine of 75 degrees. And that's divided by lowercase a, which is 24.01. So next we cross multiply and solve. So 24.57 multiplied by sine of 75 degrees, and all that divided by 24.01 leaves us with 0.9885 to 4 decimal places. And since we do not know the angle, we have to use the inverse function. So sine to the power minus 1, so the inverse function of sine, bracket 0.9885 and close the bracket, gives us 81 degrees to the nearest degree. So this angle theta is 81 degrees. So this entire angle is 81 degrees. So if we take off the 15, we figure out the angle of elevation. So 81 minus 15 gives us 66 degrees. So that angle of elevation is 66 degrees.